Okay, in this video I'm just going to do a couple more examples of integrating exponential functions. So we said these are two basic formulas and just some common tricks that you use to integrate. Again, in these examples, again, I'm just going to be using algebra and a bit of u substitution, no integration by parts. But if you've seen integration by parts, that's certainly something that's pretty common to do on these. Okay, so in my first one here, I'm going to integrate 2 to the x over 2 to the x plus 1. And to get started in this one, in the first video I did, we were able to break things up. We can't really break up our fraction here. But I think the trick to get everything going in this case, again, is to simply just do a u substitution. If I let u equal the denominator, 2x plus 1, well, the derivative of that would be 2 to the x times the natural logarithm of 2 dx. And I think in my problem, well, we've got this 2 to the x dx in the numerator of my fraction. I'm going to solve the right-hand side. I'm going to get the 2 to the x dx by itself. And to do that, I would just divide both sides by the natural logarithm of 2. So I would get du over the natural logarithm of 2 is 2x dx. So then when we do our substitution, on the bottom, that's what we're simply calling u, and the 2 to the x dx, we're replacing that with du over ln of 2. I always just like to stick a 1 on top. I'm going to pull my du over to the right-hand side. This is 1 over the natural logarithm of 2, which is just a constant, so I'm going to factor that out front. So again, if you multiply everything back together, we would certainly have, du over ln of 2 and then 1 over u. And now when we integrate this, 1 over ln of 2 just comes along. 1 over u, if we integrate that, we get the natural logarithm of the absolute value of u plus c. And again, just the same thing. Now we'll just replace the natural logarithm of u. Our u is simply equal to the quantity 2x plus 1 plus c, and now we've got our antiderivative. I think this formula, the one, I was going to say the exponential formula involving a generic, the a to the x, it seems like it's one you don't see that often, so people tend to forget it a little bit, but certainly worth remembering. I think if you're taking a calculus class, you'll see it often enough. So, okay, let's do this other example. So here we have e to the square root of x over square root of x. Almost any time, you don't have to. Anytime I'm doing derivatives or antiderivatives, I typically like to rewrite things with exponents. Okay, so I see, an exponential e. I see my e in here. Again, anytime it's not just to a single variable, e to the x, e to the u, e to the whatever, almost always, at least, part of the problem is going to be just doing a u substitution. So, again, I'm going to let u be x to the 1/2. Well, if I take the derivative of that, we get 1/2 x. We have to subtract 1, so we'll get to the negative 1/2 dx. But we can really rewrite that as 1 over 2. We would have x to the 1/2 in the bottom dx. And if I think about it, if I replace, I'm going to have e to the u. The only other thing I really want to replace is the 1 over x to the 1/2 dx, and I have 1 over x to the 1/2 dx. I've also got this extra 2 in the denominator. So what I'm going to do is I'm going to multiply, so I'm really looking at this part and all of this part. If you multiply both sides by 2, we'll simply get that 2 du is 1 over x to the 1/2 dx. So now I can do my replacing and my integrating here. So again, we're going to have e to the u, that was our substitution, and then the 1 over x to the 1/2 dx, 1 over x to the 1/2 dx, we said equivalently, that's just 2 du. So I like to pull my constants out front, and now we're in business. So e to the u is easy to integrate. You just get e to the u right back, plus c, and just like before, we'll have 2 e to the u. U is x to the 1/2. So I'm simply going to rewrite that as square root of x plus c, and now we have our antiderivative. So, alright, hopefully nothing too crazy here, just a little bit of algebra, a little bit of knowing your formulas, a little bit of u substitution, and nothing worse than that. So, alright, I hope these examples make some sense. If you have any comments or questions, feel free to post them.